Hello guys, welcome back to Maths on African Motives. Still on our revisions for trigonometry. That is, we are just going to focus on this paper so that we can check how we're supposed to attempt these typical questions. As you can see, the whole of this part here, it's trigonometry, 20 marks for that. So we shall just quickly rush through the questions and see how we're supposed to attempt this. Show that the sine of alpha is equal to the cosine of 90 degrees minus alpha, and that is 3 marks for that. Okay, so we are given the condition here to show that, or to prove that, the sine of alpha should be equal to the cosine of 90 degrees minus alpha. So what is it that you can do? It is very difficult for us to prove from the left-hand side. We just have a single trigonometry that we are given, a single trig. And here it's a single trig, but we have got 90 minus alpha here, the angle. This one can be expanded. Remember, from our compound angle identities, we referred this cosine of A minus B. So you're also having this. I'm just going to help you also to check how you're going to take it from your formula sheet. This is cosine of A plus or minus B. So as we are working with the cosine of A minus B, we are working with minus B. So it is going to give us cosine of A, the cos of B, plus, because we are working with this sign down. So the sign that you're going to take there is this one, which is down. So it will be a plus sine A, sine B. All right. But I think this one, we are much used to this formula. So I'm just going to write down this. So remember that the cosine of A minus B is equal to the cosine of A, the cosine of B plus the sine of A, the sine of B. So you're going to have the sine of A, the sine of B in this case, which is from a cos. So that is what we're gonna, because this we know this ratio between these two, or the relationship between these two, but now they want us to prove. So that is the condition there. So like I said, we are going to work from the right hand side. So from the right hand side, we are given the cosine of 90 degrees minus alpha in this case. All right, so that's it. This is our A and this is our B. So this will be our A. Sorry, let us just indicate our A, and this will be our B, like that. So meaning to say, if this is cos A, cos B, which is going to be cos 90, cos alpha, going to have the product of the cos and the product of the sine. So it will be the cos of 90 degrees, the cos of alpha in this case, right? And this changes to a plus. So that is going to be plus the sine of A, the sine of B. So it will be sine 90, sine alpha, our A and B. So that will be sine 90, sine alpha in this case. Okay. So let us check this part. We can simplify, or we can work with this one from our calculator to find the values. If you know them by head, it's fine, but you can just use your calculator at the cosine of 90 degrees, which is going to give us 0 there. So this one is a 0, so you're going to have 0 times the cos of alpha plus the sine of 90 degrees. Again, from our calculator, the sine of 90 degrees is going to give us a 1. So that will be 1 times the sine of alpha. So that is the condition that you're going to have on this part. So meaning to say, if you multiply 0 and cos, that will be a 0 there. So you're just going to be left with 1 sine alpha. If you multiply 1 times sine alpha, which is going to be equal to the sine of alpha. So that is it, guys. As you can see, we are obtaining exactly what we had on the left-hand side. In this case, we are obtaining exactly what we had from the left-hand side. So meaning to say, our right-hand side is truly equal to the left-hand side in this case. Okay, so that is the proof part. You can play around your identities and so forth. Then we are given the cosine of A is equal to 3 over 5. And also the sine of B is 12 over 13. Both angles A and B are acute. So this is very, very important. Both A and B, they are acute. So remember, from our quadrant, we have got the cast concept whereby we deal with this quadrant, which is the first quadrant, being the one that carries all the acute angles. All acute angles, they are positive in this quadrant. So meaning to say it's an indication, or it's a presentation that is very, very important to be noted, because you are told about the angle A and B. Where are they related? So if it is an acute angle, if it is an obtuse angle, the possibility of us having an obtuse angle is in the second quadrant. So meaning to say our triangle will be like this in the second quadrant. But in this case, we are dealing with an acute angle in this case. All right. So this is without using a calculator. Find or calculate without using the value of calculate the value of what cos A plus B without the use of what of a calculator. We are supposed to calculate this value of cos A plus B. All right. Let us take our values, guys. We've got the cos on of A. All right. I'm just going to remove this. So remember, we are given A and B are acute angles. That's the first thing. A and B are acute angles in this case. So meaning to say, if A and B are acute angles, they are both in the first quadrant. They are both in the first quadrant. That is the idea that you're gonna apply there. Meaning to say, we are dealing with or we are working with these two angles being in the first quadrant. That's where we have what acute angles. So in this case, we're given the ratio, or the trig ratio for cosine of A, which is 3/5. And also we were given for the sine of B, which is equal to 12/18. Remember, from our information, we're given the cosine of A, 3/5, the sine of B, 12/18, and we're asked to find the value of cos A plus B. We need to calculate the value of cos A plus B in this case. All right, so let us just have this aside. The cosine of A plus B. This is our question here. This is what we need to find. All right, so like we agreed here that this is going to be in the first quadrant. So we need to say we're just going to have a sketch of this part. Just you have to draw a sketch in the first quadrant, and also the sketch of this also in the first quadrant. So let us just have our quadrant here. So as you know, in the first quadrant, our triangle will be like this. This will be your triangle, whereby this is the angle that you're going to relate as the angle A. This is our A in this case, all right? So there we are indicating, or we are working with the angle of A. And according to that A that we are given, it is the one that we're going to use now to find or to place these values 3 and 5. From which concept, remember, the ratio of cos as a fraction, as you see it was not just written. It was taken from a ratio from our soccer to our concept. Remember, from our soccer to our concept. All right, so we have got our soccer to there, whereby the cosine of theta is the adjacent over the hypotenuse. In this case, we are simply referring to the adjacent over the hypotenuse. So wherever we see a cos, it means this is the adjacent over the hypotenuse. That is what it means. So if it indicates the adjacent over the hypotenuse, it means we are going to name according to A, which one is the adjacent according to A. So remember, this will be a 90 degrees here. So the adjacent is this side of 3. And the hypotenuse, the one opposite to 90 degrees, the one that faces the 90 degrees is our hypotenuse, which is a 5. All right, so that's it. But you can't leave our triangle like this. We have to solve for the third side, which is this side here. Just have to complete the triangle from your Pythagoras theorem. You can calculate this, remember, or you can just use your Pythagorean triples. If this is 3, if this is 5, we know that this is going to be a 4, all right, from our Pythagorean triples. But if you do not know that, use your Pythagoras theorem. The hypotenuse squared is equal to the sum of the shorter side squared. So that's it. You're going to have h being 5 in this case, all right? So that's 5 squared is equal to a squared, which is 3 squared, plus b squared, which is another side to be calculated. You can use x and y in this case because this is the x, this is the y. So you can even use x and y. It's up to you. All right. Now let us calculate the value of b in this case. If we are to transpose this to the other side, All right, we're going to have 5 squared minus 3 squared is equal to b squared, of which 5 squared is 25 minus 3 squared, which is 9, and this will be equal to b squared, and we just need the square root of this part, which is 25 minus 9, that is 16. So we're going to need the square root of 16. That'll be our b, of which we are going to have two values. There's the square root of 16 being a plus or minus. But because of where we are having, it's above the x-axis, it's on top here. So our value is going to be a positive. If it was like this, in this triangle like this, it was going to be this side a -4. But in this case, we are working with the part on top. So we're going to take the positive value of b, which is a 4. So this side is going to be given as a 4. So like I said, if you know these guys, you can just write, because we know our Pythagorean triples can be used where we can use our Pythagoras theorem. If we know them, then we can just write the answer direct, right? So the matter of just playing around your numbers and see 3, 4, 5, or even this part of 12, 18, we know that the other side is going to be what? A 5. All right, but anyways, let us prove that and see. We are going to have something of this nature. Remember, it's in the first quadrant. Like I said, A and B are in the first quadrant. So that will be the angle B in this case here. So you're going to have our angle B. So according to the angle B that we are given, it is the one that we are going to use now to fill in our triangle, as we are given the sine, and here the sine of theta, it's opposite over hypotenuse. So that means we've got opposite over the hypotenuse from 12 over 13. So it means according to B, the opposite, which is this side facing B, which is 12, the hypotenuse, which is 13. So we are left with the third side, this one, which is we are supposed to calculate our third side, just like what we did on this part to calculate 4, which was third side in this case. We are going to apply your Pythagoras theorem, which is one and the same thing like the previous part. So we're going to have the hypotenuse squared, which is 13 squared, is equal to the sum of these two shorter sides being squared. So we're going to have a and b being squared. So we're just going to have a squared plus b squared, all right, which is the b can be 12 squared. So like I said, you can even use x. It's up to you. Just use the way that you understand, all right? So that's it. 13 squared, which is 169, is equal to a squared plus 144 for 12 squared. Then you can transpose this to the other side so that it becomes a negative. So that will be 169 minus 144 in this case. And this will give us a squared is equal to, if you subtract these two, that will be a 25. All right, then the square root both sides, the square root both sides, meaning to say our a is going to be plus or minus 5. But like I said, you have to check now which side exactly suits in the a. It's on the positive side. This is according to the horizontal axis. This is the positive side. This is the negative side. So as we need this side, so we're going to take the positive value, which is what? Positive 5. So here we are going to have positive 5. So that's it. We have everything filled in from our triangle. In this case, we filled in everything. We have got triangle with the angle A, the triangle with angle B. So the question here was, we are supposed to find the value or calculate cosine of A plus B, which is cos A plus. Remember from the identity that I showed you before of the cos A minus B, we also had cos A plus B there. And I said you just have to take accordingly. So if it is cos A plus B, it is supposed to be equivalent to the cosine of A, the cosine of B minus. If it is a plus, it changes to a minus. So it's cos minus sine. If it is a minus here, it becomes a positive. So it's going to be the product of sine, which is sine A, the sine of B. That's the idea that you're going to have. And what is it that you need now? We need to substitute the values that correspond to the triangle that we are given. So that means here, this will be equal to the cosine of A. And here you already have the cosine of A. Yes, we can go back to say from, okay, I erased this part of our SOHCAHTOA concept, all right? You can still go back because it's adjacent over the hypotenuse, which is according to this, adjacent is 3, hypotenuse is 5. So it's still back because we have this part actually. So there is no need for us to work it out in that way to say we're gonna have because we're going to have the same answer. So if you have the cosine of A, just take it from the one that you're given and simplify. All right, so that means this will be cosine of A, so that is going to be 3 over 5. So that will be 3 over 5 multiplied to the cosine of B, meaning to say to this triangle, we are given the sine of B, not the cosine of B. That's the purpose of having our triangle completed so that we can find the cosine of B. So the cosine of B, according to our ratio, cos is adjacent over the hypotenuse. So it's going to be adjacent over hypotenuse, which is according to B, that's our adjacent, and this is our hypotenuse. So that will be 5 over 18. So we have the cosine of B in this case, which is 5 over 18. So that's a single part here. Minus, you move on to the sine of A, the sine of B. Sine of A, sine of B. So the sine of A we do not have. We've got the cosine of A. So we're going to find the sine of A from this part. Remember, the sine of an angle, it's opposite over the hypotenuse. According to our ratio, it's opposite over the hypotenuse. So according to angle A here, the opposite is 4. So it is going to be 4, which is the opposite over the hypotenuse, which is what? The hypotenuse, which is 5. So that is going to be 4 over 5. So you're going to have 4 over 5 times the sine of B. So the sine of B we already have. We are given the sine of B there, which is 12 over 13, like this. All right. So remember, this question is saying do not use a calculator. You're not supposed to use a calculator. So on your simplification, this is what you're going to do. You're just going to multiply what you have on the numerator. It's a multiplication. Just multiply the numbers on the numerator there. 3 times 5, that is 15 over 5 times 13, which gives us 65. All right. Minus, also multiply 4 and 12. If we multiply 4 times 12, it is going to give us 48 over 5 times 13 is same as this one, 5 times 13, where we got 65. Then from there, you can subtract, since the denominators here are the same. Remember the concept, if the denominators are the same, you can simply combine your numerators, A over B minus C over B, like this. If the denominators are the same, it means we're going to have A minus C over B, everything combined over a B. So meaning to say here, we are going to simply subtract 15 minus 48, everything over what? Over 65, because we've got a common denominator there. So if we subtract 15 minus 48, this is going to give us negative 33 over 65. And this cannot be reduced. We cannot reduce this value. So you just have to leave our answer like this. That is the idea there. So guys, trigonometry, it's something that we just need to understand, work with your quadrants, and also understand each and every trig that you are to apply or that you are to use to answer a certain question, and also application of your angles, being acute and knowing your trigonometrical ratios. It can actually help. All right, so that was 4 marks for this, and let us check 3.3, simplify as far as possible. So that one, we need this question, we need to simplify. It's like a question whereby you are given to prove. You are simplifying this to give us this. So the simplify and the proof, like I said on the introduction video, that when you're asked to prove or to simplify, it's just one and the same thing. So we want to simplify this. We are not given the answer, which means we are going to work with our own answer, but it must be in simplest form. All right, so that was 3.3. There we are given 1 plus cot squared x, everything over cot x. All right, cosec x. All right, so there we just have to play around with our identity. So I just want you to get back to your formula sheet and see some of the other things that you're given. And like I said, for you guys, most of the things they're not given, so you have to know them by heart. If you have to check here, we've got something that you're given from our Pythagorean identities. Here we have got this identity: 1 plus cot squared is equal to cosec squared x. So meaning to say, wherever we see 1 plus cot squared, we are going to replace with what? Cosec squared x. So this is going to give us cosec squared x over cot x cosec x. So as we can see, there's something that is just happened the moment we just wrote this cosec squared x. there is also a cosec x that we have. So it's not about just changing to say wherever you see a cosec, right, 1 over sine. No, we just first simplify. If like you're given an identity like this, try to have it as a single trig. Then from there, check what is happening. If there's anything, but if there's nothing there, then you have to change your cosec to 1 over sine, your cot to cos x over sine x. But here, there is something common because it's a multiplication here. So I can reduce this, the cosec of x into the cosec squared of x. It is going to be the cosec of x. So meaning to say on top, we are going to be left with the cosec of x over the cot of x. These two cannot cancel. These two, they cannot cancel. So that's where now we have to think of the equivalent of the ratios that we had from our N3. Remember, we say the cosec of x is the same as 1 over sine of x. So cosec, it's 1 over the sine of x, like this. So we're just going to have it this way. All right, divided 2. So this is dividing 2 cot x, and cot x is cosine of x over the sine of x, like this. So we've got this as a fraction and this also as a fraction. So this division here is the one that is indicated in between here. All right, so that is the cosec of x, which is 1 over sine x, divided to cot x, which is cos x over sine x. But as we know, guys, division, whenever we have got this division, we are supposed to introduce multiplication so that we can be able to simplify. So that will be 1 over the sine of x multiply. The moment you introduce your multiplication, you interchange the second fraction. So that will be sine x on top. So you're going to have the sine of x on top over the cosine of x. So that is the idea there. So you cancel the sine and the sine. As long it is in the numerator, the other one is in the denominator, it can be cancelled. So this will be a 1, this will be a 1. Once you cancel sine x into sine x, it's 1. Sine x into sine x, it's a 1. So there we can have a product. What is left can be multiplied the numerator to the numerator 1 times 1, which is 1 over 1 times cos x, which is the cosine of x. And this is going to give us a sec. Remember, 1 over cos x is equal to sec x. So that is sec x. All right, we are done in this case. So another question, or in another question paper, or in another exam or something, they are going to ask you a similar question like this, but they will ask you to prove. Now you'll be given this part here, prove that this is equal to sec x. It's one and the same thing as what you're given. To simplify, they are saying simplify this, or they can say prove that this here is equal to 1 over cos x, or this is equal to sec x. But this time it was just a simplify. So like I said, the simplify question and the proving question is just one and the same thing. Once you know how to simplify, therefore, you must be able to know how to prove. Okay, we've got a proof there on 3.5, but before that, we've got 3.4. So for x, which is an equation now, so given 5 sine squared, or just see what we have there, 5 sine squared x minus 5, the cosine of x is equal to 3. So you can even transpose this 3 to the other side so that it becomes a positive 3. This is equal to 0. All right. So when we also have an interval that you're given from 0 to 360, which is very, very important to note, because the angles there that we are going to have, there are so many angles. If you're solving a trig equation, the answers, they are actually infinite. There are a lot of answers that, so you'll be given an interval to take your answers from 0 to 360. That is what you're given there. All right, so remember what I said, if you're solving an equation, you must be able to write that trigonometric equation in terms of one trig. It's either in terms of sine or in terms of cos, in terms of tan, depending with what is easier for you to work with. So if we are to check here, there is a sine of x, which is sine squared. Here there is a cos. And it is difficult for us to change this cos to a sine because the only part that we know is that the cosine of x is equal to the sine of 90 degrees minus x. So meaning to say we are working with something complicated. This is not sine x, this is sine 90 minus x. So as we can see, it's difficult for us to work from a cos, but it's easier for us to play around with this sine squared x to be changed to be a cos, to be having a cos. And how can we do that? All right, remember from our identities, again, I showed you this part. Let me just go back again so that we properly move with together. If we check with for the first identity that you're given, that the sine squared of x plus the cos squared of x is equal to 1, which is one of the Pythagorean identities that we have there. So as we are supposed to have the sine squared, so we're just going to transpose cos squared to the other side so that we remain with sine squared. That is the idea there, because we want to remain with sine squared. So let us transpose cos squared there. So we're going to have sine squared x, which is equal to 1 minus cos squared x. So this is the one that we're going to use. As you can see, it's in terms of cos, because here we need a cos, but it was difficult to change a cos to a sine, so you have to change sine squared because we have got an identity which is straightforward there. All right, so that's it. So this will be 5 into, as we saw this one, we changed it to be 1 minus cos squared x. So this is what we now have. All right, the rest is going to remain as it is, minus 5 cosine of x plus 3 is equal to 0. So we just wrote what is equal to sine squared x, but in terms of what we have here, we have got cos x. So now we also have a cos there. So it can be solved. If it was easier for you to change this cos to a sine, you work from there. But as you can see, it's very, very complicated there. So we can expand our brackets. As you can see, we just left with just like we have got a normal equation, like normal quadratic equation that we are used to. So what we need there is the format. Remember, if we are having our normal quadratic equation is supposed to be ax squared plus bx plus c is equal to 0. So let us just have that. All right, so we're going to expand brackets. 5 times 1, which is 5. 5 times negative cos, which is negative 5 cos squared x. All right, then here we've got negative 5. The cosine of x plus 3 is equal to 0. So that is a 0 there. All right, it's equal to 0. So the question is, how are we going to formulate this to be in this format? Because this is the format of a quadratic equation. And because of the highest exponent, which is 2, that's why we have to think of this format. So we are going to start with the one that has got the highest exponent of 2, which is negative 5 cos squared x. All right, we move on to the x, which is like bx, which is negative 5 cos x in this case. All right, so we've got negative 5, the cosine of x, then the constant, which is the c. We've got the constants here, which is 3, 5, and 3. So we're going to add these to 5 plus 3, which is 8. So this will give us a 0. So that's it. We've got your quadratic equation in terms of a trig. So you can solve this trig equation that we have using your quadratic formula. If possible, you can introduce another letter in terms of what you want. Also, you can even take rid of the first term to be a positive. So you just have to divide by negative throughout so that this term can be a negative. I just have to divide by negative 1, negative 1, negative 1, negative 1, each and every term. So this will be a positive. So we'll be having 5 cos squared x, negative here is going to be a positive again, 5 cosine of x, positive and negative, it will be a negative, which is equal to 0. 0 divided by a negative, 0 divided by a number, it just remains as a 0. So that's a quadratic equation that we are seeing, which is the same as the one that we are seeing of the form of ax squared plus bx plus c is equal to 0. So as we know that if it was like that, in order for you to solve for x, you are going to use it. X is equal to minus b plus or minus this and that. You are solving for x. It's from ax squared plus bx plus c is equal to 0. X is the one that is directly affected here. What is containing x? It's cos x. It's not just x there. It's cos x, not x. So meaning to say, we are going to have our formula, same as our formula that we are used to, but it will be cosine of x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. So this will be our formula now, cos x, not to say x is equal to, because this is not affected x direct. It's cosine of x squared. We have got cos x there. So it must be cos x is equal to, all right. So that means the cosine of x will be equal to negative b. Remember, this is our a, this is our b, this is our c. So b being positive 5, so it's going to be negative 5 plus or minus the square root of b squared, which is our b again, that will be 5 squared minus 4 times a, our a, which is 5 times c, or c is negative 8, like this, okay? So this is what you're going to have, everything over 2a, that is 2 times a. Remember, our a there is 5. All right, so that's it. We can solve for x in this case. This is cosine of x. So we shall have cos x. Then from that cosine of x, we find the values of x. Remember where you have to find the reference angle, this and that. But the first thing is to have the values that corresponds to the cosine of a, the decimal part of the cosine of x. So we need our calculator there. So let us just see on our calculator. So you can simplify direct, but the first thing that I want you to do is to simplify just this part here under the square root. Do not use the square root at first. That's that part alone under the square root. This one, 5 squared like this, minus 4 times 5. All right, there's too much there. 4 times 5 times negative 8 without the square root. Without the square root, it's 185. So meaning to say we've got the square root of 185 there. It's very, very important to do that so that you can see if the answer there is a positive or a negative, because if it is a negative, it means you can't simplify that. All right. Remember, from our complex numbers, we have got the issue whereby we have got a negative. So that is why I'm saying you are supposed to cross-check and see about this. But from the later stage, you can simply you can simplify everything direct. The cosine of x is going to be equal to, let us have the first part here. We've got negative 5. That's negative 5 plus the square root. So first we're going to work with the plus there. So we're going to have plus the square root of 185, everything over 10, which is 2 times 5, which is what? Which is a 10. So that is going to give us 0.86 this and that. So you can even round off to 3 decimal places. That's shift set up. You go to the fix there on 6, then to 3 decimal places, you fix it at 3 there. So it is going to give us an answer 0.860. So meaning to say I've got a 0.860 there. Or you're going to have another cosine of x being equal to, we just have to put a negative this time. All right, so just going to have to put a negative here. All right, so that delete this and put a negative there. That will be to 3 decimal. Already this one is given to 3 decimal places. Negative 1.860, negative 1.860, like that. All right, so these are the possible values of cosine of x, but that's not the x that we are supposed to have. This is cosine of x, not x, as we need to calculate or to find the value of x, which is carried by cos. The x that we need here, it's carried by x. So remember what I say, that you're supposed to find the reference angle, then you consider the quadrants according to the interval that we are given here from what? From 0 to 360. Remember, we are given that our x is supposed to be taken from 0 to 360 degrees. So we are supposed to consider the interval. All right, so let us consider the first one, this one being the cosine of x being 0.860, and it's a positive. So if it is a positive like this, it means we are referring to which quadrant? From the cast concept or from the all students take calculus. Cos, it's positive where, because we are dealing with cos being a positive. If this was negative 0.86, you take where it is a negative, but there it's a positive. So cos is positive in the first quadrant and also in the fourth quadrant where they see here a cos. So in the first quadrant, remember I said the actual angle, which is our x, will be equal to the reference angle. In the second quadrant, our x is going to be 180 degrees minus the reference angle, because we'll be talking about this angle here. So it will be 180 minus reference angle here. We are going to add the reference angle. X is going to be equal to 180 degrees plus the reference angle. In the fourth quadrant, our X, which is the actual angle, is going to be 360 degrees minus the reference angle. So as long as you understand that the reference angle has to affect each quadrant. So here we are dealing with the part where it is positive, and we are dealing with the first quadrant and with the fourth quadrant. So meaning to say, let us find the reference angle. Remember, the reference angle simply means the arc cos of this value from your calculator. It simply means arc cos like this. This is what I'm trying to say. Remember, we've got 0.86. So shift cos like this, 0.860. All right, like that is the reference angle, and that is taken. You use this value as you just take as a positive, even if it was a negative here. The negative is the one that is described by the quadrants. Here you just take positive values only here. All right, so you're going to have 30.683. So that will be 30.683 degrees. That is our reference angle in this case. All right. So if this be our reference angle, what about the actual angle now? Because we are talking of the reference angle, but we are supposed to find X, which is being what? The actual angle in this case. So we have got X in the first quadrant is the same as the reference angle. So this one is not going to affect us. So X is going to be equal to the reference angle in the first quadrant, which is our reference angle is what? 30.683. All right, that is in the first quadrant. The other X that we're going to have, because of cos being positive, our cos is being positive in the fourth quadrant. So it's going to be in the fourth quadrant where X is equal to 360 degrees minus the reference angle. So you're going to subtract the reference angle, which is 30.683 degrees. All right, so this will give us the value of X, which is 329.317 degrees. So we have another X, and from the interval that we are given from 0 to 360, this is what we can take. We can't take any other angle more than this. That is what we can have. From 0 to 360, you just work with your complete quadrant from 0 to 360. Remember, this quadrant is giving us our angles from 0 back to 360 degrees. Then if we check on the other cosine that we obtained here, we obtained that the cosine of X is equal to negative 1.860. Remember, from the graph of cos, it is something of this nature. This is the graph of y is equal to cos x. This graph of cos x cannot exceed 1, cannot exceed minus 1. I'm saying cos x, not 2 cos x, not 3 cos x. I'm saying the graph of cos x, because here we are given as cos x is equal to. So this graph of cos x cannot exceed 1, cannot be below -1, like -2, -3. It can't be like that if this is direct what? Cos x. So meaning to say this is out of the range. We cannot find solutions on this. This is not applicable because it's -1.86. But if you want, because the calculator knows everything. So if you do not know this, then you can just go back to your calculator, because remember, you're supposed to have the reference angle. So you're going back to say, now I want to calculate the reference angle. And like I said, the reference angle, you don't put the sign there. The negative is just for the quadrant, but you just have to put it this way, shift cos 1.86 like this. You see that there's nothing there. So it will write Met's error to show that we cannot have any value above or below this interval from this range from -1 to +1. If it is cos x, it can exceed. If it is y is equal to 3 cos x, yes, we can have that at 3 and -3, not cos x direct like this. But if there's a number multiplying, it can even go beyond -1 and +1. So here we do not have solutions on this part. So that means the only answers that we are going to have at the end are these two that we obtained from cos x being equal to 0, 860 there, which we took from the first quadrant and the fourth quadrant. So therefore, x is going to be equal to 30,683 degrees, or it's going to be this, or x will be equal to 329,317 degrees. So these are the possible values of x that we can actually relate or use in this scenario. The other part, we do not have solutions there. All right, so as you can see, it's just something that you need to play around, understand how you're given this question. This is very, very important. All right, let us check 3.5, which is the last part of the question that you're given. 3.5, prove that this must be equal to this 4 marks for that. All right, let's just see how are we going to work with this identity here. This is 3.5 and got a proof there. So I'm just going to take most complicated part where we've got a lot of things, which is the left-hand side in this case. So I'm going to work from the left-hand side. So from the left-hand side, I'm given 2 sine of y in this case plus 1, everything over sine of 2y in this case, plus the cosine of y like this. All right, so it seems like it's a complicated thing that we have, that we must prove that this is equal to sec x. All right, this one was not much complicated. Remember, from our double angles, we've got the identity for the sine of y, which is sine 2y, which is 2 sine y cos y. All right, if you're given the sine of 2a from our double angle identities, it is equal to 2 sine of a, the cosine of a. Just the product of sine cos. So you're going to multiply it by 2. And I'm just going to have another video just to work with the half angle, because these are double. When you see 2a like this, it's double angle. That one, it's a double angle. Then if you see an a over 2 like this, cosine of a over 2 like this one is a half angle. These are half angles now. So you're going to talk about that if we just find time. But I think I mentioned 1 or 2 as we're revising. So the first part, there's nothing that we can do on the numerator. I'm just going to rewrite as it is. There's nothing there. Someone might think, okay, there's a 1 there. What if I change this 1 to be cos squared, cos squared y plus sine squared y like this? Guys, you are complicating a lot of things, because you're going to have cos squared, sine squared. Here there is sine y. So we are going to have a lot of complications there. So let us just leave it like that. Let's work from the second part. So the numerator, just rewrite as it is 2 sine of y in this case plus 1. So we saw something in the denominator there on sine 2y. Like I said, this can be given from our identity. The sine of a is equal to sine a cos a. So we're going to have the 2 sine of y in this case instead of a, then the cosine of y in this case plus the cosine of y, just rewrite as it is like this. All right. So if you check from this simplification, it is like we now have something that can be related in this denominator here. There's something that we have there that we can consider. What is it? We have got the common term, the common trig, which is the cosine of y and the cosine of y. So you can factor out, just like we've got ax plus x like this. If x is common, factor it out, remain with a plus 1. So that is the same condition that we're going to have here. So that means we're going to have the sine, 2 sine of y plus 1, everything over. You factor out your common term, which is the common trig that we have here, which is the cosine of y. So if we factor out this, that will be the cosine of y into, all right, divide, that will cancel, the cos and the cos will cancel. Remember, we are dealing with the 2 sine of y, the cosine of y over the cosine of y like this. So at the end, this will cancel. We remain with 2 sine of y there. So you're going to have 2 sine of y plus cosine of y divided to the cosine of y. These two cancel, so this will be a plus 1. So as you can see, this is very, very similar. It's actually the same as what we have in the numerator, the bracket that we have in the denominator, and this part is the same. So it's just like we've got something like this. So this and this part can cancel. Just talking about the one and the same thing. So if we divide this, that's a 1. Divide this, that will be a 1. So in the numerator, we are left with 1. So this is going to be 1 over. In the denominator, we are left with cos y times 1. So this will be cos y in this case. All right. But we know that 1 over cos is equivalent to what? To sec. So whenever we have got 1 over cos like this. This is equivalent to the sec of y. So know this, guys, 1 over the sine of y is going to give us cosec. All right, the cosec of y. But if it is 1 over the cos of y, it will be a sec y. A sec y. All right, so that is what you're supposed to have at the end. And this is exactly what we have on the right hand side. So meaning to say our left hand side in this case is equal to the right hand side. That is how we're supposed to work out this. So like I said, just play around with the most complicated part where we've got a lot of things than to work from a single term. Just like this part here, we asked you to show that, which is to prove again. This is to prove we work from where we have got a lot of things than to work from a single term. Avoid that condition of you going back to a single term. So as you can see, it's just actually 4 marks. It's actually fine to obtain 4 marks there. So these are the steps that we just needed, which is something that you need to revise also. Like I said, work with your identities, work with your ratios, and also how to solve your equations. That is the whole part of your trigonometry. If you can understand that, it will be fine. So also revise from your N3, because this is a continuation that we have of our N3, those quadrants, the issue of equal angles, positive and negative angles, and so forth, and also how to relate your quadrants as you take them from the quadrants. Your identities, definitely you are supposed to know each and every identity. Yes, we've got some of the identities that we are given from our formula sheet, but some we are not given. So we need to understand all of our identities to answer these typical questions.